Hello, and welcome back to More Math. As you recall, last time we got together, we were talking about greatest common factor. Well, we're going to build on that today, and we're going to talk about least common multiple. Least common multiple. Hey, if you didn't watch greatest common factor, go watch it real quick, because I actually build on it. That's the funny thing about math. I learn something, then I use it again the next day for something new. So if you didn't, please watch greatest common factor real quick. As I go through the video, I'm going to do some things. If you need a moment, don't forget, you could hit pause, right? Sometimes I get excited. I mean, we're talking about math, which is awesome. So I get a little excited. I might go a little quickly. If I do, just hit pause. Make sure you've got a piece of paper and a pencil because you want to do it with me. Boring to sit and just watch. So grab a paper and a pencil, hit pause. And here we go. Let's talk about least common multiple. Like we talked about last time with greatest common factor, let's take a look at what the words mean. I've got least common multiple. Don't you love that color? We've been able to adjust things a little. It looks great. Anyway, the LCM, least, L, least. What on earth does least mean? Is that something really big? No, the least is the smallest, right? The least means I'm going to look for all these words. All we need is smallest. It is the most little one there is. Common. That sounds familiar. That's like what we talked about last time. What does common mean? It means each person has it. We're going to talk about some numbers and find their LCM. That means this is going to be a multiple that each one of them has. They all share it. And that last word I just used was multiple. And a multiple, those are numbers that I can multiply with another number to get a product. It's like a factor, right? But it's a very specific one. Specifically, we're going to talk about skip counting. So let's just jot a note. The least is the smallest. The common means, how can we write that short? How about everyone has? That works. And then multiple, we're going to think skip counting. So we understood, didn't leave myself much room there, did I? All right, so we understand the idea of least common multiple. It's the smallest number that is a multiple of both the ones we're looking at. How are we going to figure that out? We're going to use skip counting. So let's start there. Skip counting, well, that's easy. You've done this like since elementary school, right? So if I said we had the number 3, well, how do we skip count with 3? It would be 3, 6, 9. In other words, it would be 3 plus 3 plus 3 plus 3, 12. Or we could multiply. We could say this is 3 times 1. This is 3 times 2 is 6. This is 3 times 3 is 9. This is 3 times 4 is 12. That's all skip counting is. It's just increasing by this number every time. 3, 6, 9, 12. Let's do another one. How about, let's just do 4. We could say, here's 4. What are the multiples of 4? I rewrite the first one. Some people don't. I think it's just up to you. So we've got 4. 8, we said 4 times 1 is 4. 4 times 2 is 8. What's 4 times 3? You got it, 12. If we add 4 more, or say 4 times 4, what do we get? We get 16. And we can just go on and on and on, right? That's what those 3 dots mean, on and on and on. It's called etc. So this is skip counting. Okay, that makes sense. Another word for skip counting that we just learned is a multiple. These are the multiples of 3. These are the multiples of 4. So now when we think about the least common multiple, we're thinking about what's the smallest number they both have in common. Let me erase something here while we're talking about it. If we want to figure out the smallest number they both have, look how we just wrote them out. I'm getting these out of the way so they don't confuse us. Can we look at these and can we find something? Can we find common multiples? What's the smallest number they both have? I don't know. Let's look. Well, there's a 3 here. Is there a 3 down here? There's not. So we know 3 is not a least common multiple. Well, there's a 6 here. Is there a 6 down here? 16, but that's not the same thing, so that doesn't count. 9. 9's a nice number. 4, 8. There's no 9. That doesn't work. 12. We found a 12. Is there a 12 down here? There sure is. Look. Both of these skip counts, both of these multiples have 12. We just found the least, the smallest, common, they both have it, multiple. We skip counted, multiplied by 1, by 2, by 3, and they came up to 12. Here's our least common multiple. And how did we find it? We used skip counting. Easy peasy. Nice job. Well, that wasn't too hard, was it? We just wrote the number, and then we put out the multiples. We found the smallest number, the first number, they both had the same, and that was our LCM. What if we start getting with bigger numbers though? The LCM, the multiples, for example, of 12 and 18. We're getting into some big numbers there. You know I've got a way to do it much easier, right? We do. Last time we talked about greatest common factor. We're going to use that upside down division again to find the LCM. Watch this. Do you remember how we set it up? You're doing this on your paper with me, right? Don't want to just watch. Boring. So grab that piece of paper and pencil that you have, and we're going to put 12 and 18. And now we're going to put that upside down divisor on here. And do you remember what we do now? Yeah, we're going to look at this and we're going to say, what's a factor I can pull out of both of those? We're going to start with the prime factors because I like the practice of it, but if you know a bigger one, that's okay. Let's see. Remember, we start with 2 and we look at it and we talked about that we know that 2 is a factor if they're even numbers. Is 12 an even number? Of course it is. It ends in 2 and we know that 2, 4, 6, 8. Who do we appreciate? Even numbers. 2, 4, 6, 8, and 0 are all even numbers when they end in that, so we know it's divisible by 2. Is 18 divisible by 2? It is, because it's also an even number, so I'm going to put this 2 right here. And now we're going to say, what is 12 divided by 2? You got it. It is 6, easy peasy. What is 18 divided by 2? That's right, it is 9. So that was pretty easy. We went through, we pulled out that common factor of 2. We're seeing our upside down division here. Can I pull out 2 again? And we know we cannot. Why? Because a 9, it's not even, is it? So I know from now on, no more 2s. Can we pull out a 3? Yes, we can. Let's do that upside down division again. Here's our 3. What is 6 divided by 3? You got it. It is 2. What is 9 divided by 3? It is 3. Oh, now you watched that last video, so you remember that when my final factors here are in a row, they're like counting numbers one right after the other, we know we're done. There's going to be no more factors. Once this is 2, 3, or 7, 8, or 39, 40, we know we're done because there's no more factors that'll go into both of them when there's only a 1 number difference between them. So we got 2, 3. We know we're done. Now we know a few things. Remember what we did last time? What was our greatest common factor? Do you remember how to find it? Can you put a C over it like we did last time? Let's see. Did you put a C right here? Did you go, here is my common factor? That's it, right? So our greatest common factor is 2 times 3. And what did we get? 6. All right, so we know that our GCF is 2 times 3, which equals 6. That was going to be an equal sign, and I changed my mind where I was putting it. All right, but we're not looking for greatest common factor this time. Oh, so let's erase that C, because that's not what we're doing. But you're going to find out the setup is exactly the same. When you do this work, you're finding the greatest common factor. The bright lights make the ink dry really fast, so it gets a little stiff sometimes. Okay. When we set this up like this, we found the greatest common factor here, but guess what else we found? Look at this. I can draw Do you see my letter L there? This is an L. Here's an L. L stands for least. I can multiply all of these together, and that's going to tell me my least common multiple. Let's try it and see if it works. We've got 2 times 3, and you remember we're using the dots for multiplication because we know later on in the year we're going to be using X's for other things, and we don't want to get confused. So we're saying 2 times 3, and I'm going to do it again, times, here's another 2, and times this 3. Do you see how it came from here? And I just brought them down. And now I'm going to multiply them together. What's 2 times 3? 6 times 2 is 12. Nice job. Times 3, 36. You guys are so smart. Oh my goodness. The LCM is 36. Let us stop and admire for just a moment. We did upside down division, which tells us the greatest common factor. But now we took it a step farther and we said, not only do we know that 6 is the greatest common factor, number I multiply together to get this number, but I can multiply that greatest common factor times the leftovers, like last night's meatloaf. I multiply them all together and it tells me the least common multiple. 36. I have a question for you. Is 36 bigger than 12? It is. So if we skip count, let's see what happens. We get 12, 24, 36. There it is. Ooh, what about 18? Well, we get 18, 36. Oh, we already got there. So multiples of 12, 12, 24, 36, 18, 36. 36 is the least common multiple. Do you see how easy that makes it? Isn't that beautiful? I love math. I'd like to try another one. Let's find the least common multiple, the LCM, of 12 and 20. And why do I want to know this? Well, I've got a little business at my house, and I'm stacking boxes, getting them ready to ship, and I'm going to stack them up. And I want to know if I stack up all these boxes that are 12 inches high. Here's my 12-inch boxes. That's not very accurate. Let's pull that down a little. That would be like here maybe, right? If these are 12 inches, that's not very accurate either. Ignore the drawing. And this is 20 inches. I want to know how many do I have to stack before that's going to be level. At one point, when I have a stack of boxes that are 20 inches tall and a stack of boxes that are 12 inches tall, how many boxes do I need of each till it's level? Least common multiple is going to tell me this. All right, so we're going to use that upside down division that we really like because it makes it so easy. And let's face it, math's more fun when it's easy. So we're going to do it upside down division. So I'm going to put 12 and 20. I'm going to put my divisor upside down. There's my little divisor bar there, right? And now I'm going to do the same thing. Let's find our least common multiple. Well, I'm going to pull out a 2 because they're both even, right? We see that here's 2 and 0, both even. I can pull out a 2. And what am I left with? 12 divided by 2 is 6. 20 divided by 2, 10. Nice job. They're both even again. Let's pull out another one because they're still even. So I can pull out 2 again. 6 divided by 2 is 3. Good job. 10 divided by 2 is 5. Nice. Are we done? Ooh, but they're not, it's not 3, 4 or 5, 6. They're not right next to each other, but we are done. I did warn you in the last video that doesn't work every time, that's not going to happen. So this is an example. The only factors of 3 are 1 and 3, and 5 is 1 and 5. So we're done here. We've gotten to the end. So now we're going to find the least common multiple. So we're going to make our little L, right? Here's our L. We're going to multiply them. We're going to multiply everything in the L. We're going to say 2 times 2 times 3 times 5 equals. So 2 times 2, remember this was our GCF. This is leftovers, like last night's meatloaf. And we multiply it all up. We get 2 times 2 is 4. 4 times 3 is 12. 12 times 5 is 60. Nice job. So what we did is we took the greatest common factor, 2 times 2, times the leftovers, like last night's spaghetti, 3 times 5. We multiplied them all together, and we got 60. 60 inches. So we had 12 inches and 20 inches. So I know that when I stack those boxes and I want it to be even, how high is it going to be? That stack of boxes is going to be 60 inches, which is like 5 foot, right? So, you know, pretty tall. I got to be careful, make sure it's safe. But now I know that I could stack it up against the wall, right? Least common multiple. At what point will they be the same height? They will be 60 inches. They will be the same height. Pretty cool. We're going to try one more example. We're going to go through it a little more quickly. But why don't you try it on your paper first? We're going to find the least common multiple of some trains. Train A shows up at the station every 12 minutes. Train B shows up every 15 minutes. And train C shows up every 18 minutes. How long will it take for all three, if they all start off at the same time, how long will it take for them all to be back at the station at the same time? When are they all going to be there at the same time? I don't know. Let's find out. We need the least common multiple. So how we did that with 2 numbers, we can do the same thing with 3 numbers, 12, 15, and 18. We're going to do our upside down division, and we're going to look and we're going to think, can I pull 2 out of all 3 numbers? I can't. This one's not even. Can I pull 3 out of all 3 numbers? Yes, I can. I'm going to pull out this 3 and do the same thing we did before. It doesn't matter that I have 3 numbers here. I could have any number of them. Gets a little harder, but we can do it. What's 12 divided by 3? It is 4. Nice job. What is 15 divided by 3? It is 5. What is 18 divided by 3? It is 6. Oh, look, we're already done. There's no more because it's 4, 5, 6. Remember we talked about in counting order, we're done. But look how easy it made it just to set it up like this. Well, we're going to do the same thing. We're going to find our least common multiple. Here's our L. We're going to just multiply them together. So we'll have 3 times 4 times 5 times 6. So let's see what we got here. 3 times 4 times 5 times 6. I'm cheating and looking at my number while I wrote it down already. It's going to be 180. You can use your calculator. I did, maybe. Shh, don't tell. So we got 180. So every 180 minutes, all 3 trains will be in the station. So 180 minutes, do you know how many hours that is? Yeah, that would be 180 minutes divided by 60 minutes per hour. So it's going to be every 3 hours. Good job. So we know, so let's say they're making plans for that railroad station. How often are we going to be super full with everyone here at the same time? Every 3 hours. If I was going to go to the train station and sell something just a couple times a day, like stand on the corner and sell flowers or whatever, I would want to go every 3 hours when all the trains are going to hit there and there's going to be the most people. Least common multiple. Kind of useful. The last thing I want to look at is some fractions. We want to compare these. I can't compare 5, 6, and 7/10 because they have different denominators. So I need them to have the same denominator. Denominator, number on the bottom, right? How can I do that? Well, the number on the bottom, I want it to be the least common multiple. So what is the least common multiple of 6 and 10? Well, let's see. I've got 6, 12, 18, 6 times 4 is 24, 30, and then we got 10, which is 10, 20, 30. My least common multiple is 30. I could have done upside down division too, but this time I thought, I already know it's 30, so I just kind of showed it here, right? So what am I doing? I want this to be 30 to show the comparison. So I would say, what is 6 times what is 30? 6 times 5. And as long as I do the same thing on the top, we'll talk about fractions more, but we know that this is 25 over 30. Down here, how do I make 10 look like 30? I multiply it by 3. So if I do that on the bottom, I'm going to do it on the top. So we get 21 over 30. Again, we're going to talk about fractions more. I just wanted to point out that least common multiple is used in fractions to find the denominator. So we know that 5/6 is bigger than 7/10 because 25 over 30 is bigger than 21 over 30. So least common multiple is really helpful here also. When we get to talking about fractions, you're going to find that we use it a lot. You guys have done a great job, and I hope that you have enjoyed learning about least common multiples today. It really built on our last lesson, so keep up, keep going. I believe in you. You're doing great. Come again. All right, I'll be quiet. Have a good day.